Hello everyone, welcome back to another video for the series. I'm InnoQ and today we'll be solving 2026 Polish Final Math Olympiad Problem 3. I think this team selection test was held this March or April, and I found this problem to be very interesting and also elegant, so I decided to share it here. Without further ado, let's get started. Let the sum of x of I equals 1 for x of I greater than 0, and we want to show that this inequality holds. Now, the very first thing that I tried is actually multiplying this term to here. So we got equals 1 and like this. The reason why I did this is because when we actually expand left hand side and right hand side, we will get x sub I to the power of 4, and I thought it will nicely cancel out and solve this problem, but that wasn't the case because we have square root of n here, and when we actually try to expand our expressions, our terms get very messy. So I quickly had to give up on this approach. Now, the reason why I think this inequality is very elegant is because we don't need other fancy inequality theorems, but we only need Cauchy-Schwarz inequality. I mean, Cauchy-Schwarz inequality is very fancy too, but it's one of the very basic inequalities. So what we're going to do here is, first of all, we want to show that it suffices to prove that we don't want square roots here. So it suffices to show that I equals 1 and is greater than or equal to this thing squared. So we got n xi cubed squared. Now this is true because let's just take a look at this. So if this is true, then this is true. But because it's a and b is positive in our case, this is true. So if this, and because a and b are positive, this is true. So it suffices to show that this is true. Now let's modify our left hand side a bit. We can change this to equals 1 and cube times now we can write n as n and 1. Now let's leave this here for a bit and let's use Cauchy-Schwarz inequality. Yes, let's use Cauchy-Schwarz inequality here. Continuing, we know that this is greater than or equal to and applying Cauchy-Schwarz inequality here, it is simply x sub I squared. Okay, now we know that because by definition, the sum of x sub I from I equals 1 through n is equal to 1. So we have this equals n x sub I squared cubed. Therefore, it suffices to show that equals 1 cubed is greater than or equal to equals 1 and cube squared. Yes, we just need to show that this inequality holds and we are pretty much done. Now, how can we prove this? Again, we could do, yes. Let's first modify our right hand side first so that we can write this as x of 1 squared to the power of 4. We know that this is true. Now, we know that this is also less than or equal to times I equals 1 squared, because obviously when we expand that, we know that this is greater, but it's also our equal condition it's not strict inequality because n can be equal to 1, because 1 equals 1, so we have to put it here. And rewriting this, we get this equals I equals 1 and x cubed. Oh, so we just proved it. We proved that this one here is less than or equal to this one right here. So that proves our inequality. Now, my writing is quite big here, but yes, this is it for this problem. And I think this problem is really interesting because we solved everything just by using Cauchy-Schwarz inequality and smart substitutions, I guess. And I think it was a very fun and elegant problem. If you like this problem, please don't forget to like it, like the video, and share this video with everyone who you think would enjoy this problem. Thank you so much for watching this video, and I will see you in the next video. Bye.